Recording in progress.
Okay. So the first thing we usually do is ask if there's any folks who haven't been on this monthly meeting before and would like to take a moment to introduce themselves.
Can you hear me?
Yes.
Yeah, I mean, I've kind of gotten into the meeting. I've tried to pay attention to what
Hey,
goes on.
Steve Cohen, I think you're on twice on
Steve
Zoom.
Cohen, I think you're on twice. Steve Cohen, I think you're on twice.
What's going on? What's going on?
There, can we try it again? So I've been really impressed with the forum and all the pictures and things like that.
Still got an echo.
Steve, you need to mute yourself.
Are we okay? Oh,
Steve, you're logged in twice. I see two Steve Cohens on the view here.
Okay.
You must be logged in through two devices.
I don't think so. All right, let me exit this one.
Okay, he's muted now.
He's muted. Okay. Yeah, my name's Bob Williams. I think Greg's been over to my house once. I've started I've got a 10-foot dome in my backyard observatory, and I've been working on it for 2 years. And I'm getting close to almost being able to take pictures. I've had David Klein from Starzona come over and help me, and then I've had a lot of help from Tanner Campbell, who works for the University of Arizona. I think he does a lot of the observatories over at Biosphere 2. And he's helped me, at least when I load up Nina now, that everything comes in green instead of red. So I'm almost able to start Nina. We were actually shooting some stars last night, and my telescope was actually going to the stars. But I have a couple of questions. I hope it's okay if I can ask them. I've had trouble with Nina, where I plug in the dimensions of my observatory on the observatory app part of Nina, and then the next time I start up, all the dimensions have disappeared, and then then it won't let me use the Nina won't let me work until I can figure out what the dimensions are to put back in to the observatory part of Nina. And so that's one question. The other question is because I assume I'm a beginning photographer, even though I have basically only taken pictures of the stars trying to align the telescope. But I have a hyperstar on my telescope, and I assume that's probably the best way to go for me. Even though I know, Greg, your beautiful pictures of Saturn and Jupiter that you've put in, I'm sure you're not using a hyperstar. You have to use yeah, but I think you're using an 11-inch telescope, right? For those
Yes.
shots? And that's what I have in my observatory. So I'm in awe of all of you people because you seem to know what you're doing, and I just seem like I'm a bassoon player basically. I was a professional bassoon player who is trying to get into astronomy a little bit because I moved back to Tucson, even though this is my hometown. So anyway, so the first question is why would Nina lose? I thought it was supposed to save everything as you plug it in. And then the other thing, basically, I guess I should stay with the hyperstar if that's correct. So a couple of questions.
Any help for Robert? I know we have some Nina users, but I'm not sure if any of them use the observatory part of Nina.
Yeah. I have SkyX too, but I've never used it. But I don't know what the I've got my 10-foot dome is from Technical Innovations. It's a home dome. And I think when I talked to the gentleman that runs that company, he recommended SkyX, and then everybody else that I've spoke to seems to like Nina because it seems to be, an ongoing app that seems to keep getting better, if that makes sense.
You may have to search around online to find somebody who's using Nina to control their dome.
Okay.
Good.
All right.
Any other new folks? Randy, go ahead.
Yeah, regarding your question, Hyperstar is a great way to start
on the C11, it's really a good machine. I used it for quite a while. You can shoot off the back. That's what Greg is doing. And he's doing it in a sophisticated way with Barlows and all. You may eventually want to do that, but I would say stay with the Hyperstar C11. You'll get good results, and it's relatively easy. So that's my advice.
I don't think anything is relatively easy, at least from where I've been going on.
Well, relative, relatively.
Yeah.
If you tried what Greg is doing, you would agree the Hyperstar is easy.
Yeah, I realize that. Thank you. So,
Okay, any other new folks that want to introduce themselves? I guess you've all been here before. Any other beginner questions? Okay, well, hearing none, I'm your featured speaker this evening, so let me share my screen. Of course, the little icon is hidden behind the. There we go. Can everyone see that?
Yes.
Yes.
Okay, well, as it turns out, this month, February, is the 10th anniversary of when I moved my imaging equipment to a remote observatory. So I suggested to Jeff, and he thought it might be appropriate to spend a few minutes going over my experiences, what I learned, and the mistakes I made. And so hopefully, if you're thinking about doing remote observing, or if you have an observatory in your backyard, you may find some of the things that we encountered useful. I'm going to try to keep the comments for the next few minutes generic. In other words, I'm not going to talk about a specific remote site or the cost of the equipment or any of that, but rather try and just speak in some generic terms about what my experience has been. And feel free as we go along here to jump in and ask questions. You don't need to wait till the end if you have a question. So by way of background, I thought it'd be useful to have you think back to where you were 10 years ago in 2016. And I've listed in these bullet points some of the technological things that I thought might jar your memory. So if you remember back in 2016, Windows 7 was probably the most widely used program in the Windows genre. Windows 8 was around, but a lot of people were having a hard time adapting it. And Windows 10 had kind of been introduced just a few months before the beginning of 2016. So that kind of gives you a feel of where the computer program aspect of remote imaging was. In terms of the iPhone, we were up to the iPhone 6 way back then. The 7 and the SE were released later in the year in 2016. And then the last 4 bullet points are some of the software that was available for controlling your telescope and camera, whether you did it in person or remotely. And so I think many of you will recognize some of those. The SGP had been around for a while. The SkyX Professional had been around for a while. Maxim DL was in its 6th version, and ACP was in its 8th version. So that's the milieu in which I was trying to make a decision as to what I needed to do to get into remote imaging. But to really understand how this started, we have to go back even further. And that is, Robert mentioned just a few minutes ago about his 10-foot pro dome. Well, you see in my backyard here in the suburbs of St. Louis was my 10-foot pro dome, which I had had there for several years, used it to keep my telescope set up and ready to go at a moment's notice. And then as the years rolled on, I actually automated the dome so I could control the shutter and the rotation of the dome remotely, at least remotely from my office in my house, so that I didn't have to walk out through the snow in the winter or the mosquitoes in the summer to open the dome and begin imaging. And around 2007 and 2008, I decided to treat myself to some what I considered high-end imaging equipment. So I got a hold of an ASA 10-inch Newtonian astrograph from Astro Systems, Austria, and I coupled that with their preferred imaging equipment, which was an SBIG STL 11,000 CCD. That was a full-frame CCD that had a guide chip mounted along with it, next to it in the same focal plane, and also supported an external guide camera. So there are two different ways of guiding this particular imaging device. I also invested in a Astrophysics 900 mount, which at that time was one of their premier mounts for handling the equipment that I had intended it for. I also had in the observatory a professionally done pier from the Lasser company on which the AP900 was mounted. And so I had all of the stuff that I needed to do remote imaging. And in fact, I was able to do remote imaging from my house to the backyard observatory. And I was approached by one of our club members, I'll call him Dan, and he convinced me that I should go in together with him and another gentleman who I'll call Andy. And they convinced me that it was worthwhile to move my imaging equipment to a remote observatory somewhere in the desert Southwest. So the thing that convinced me to pay attention to these guys was that Dan was a IT guy who specialized in telecommunications, and Andy was a software engineer who was one of the developers of PhD2. And so I figured, well, with these two guys as partners, I should be able to do remote imaging. So we decided to go in together and look for an appropriate site to share a roll-off roof observatory. This is a schematic of what we came up with, what we decided to invest in. And as you can see, it's a building that was 24 feet long and 16 feet wide, east to the left, north to the bottom there. And it had room in the 16 by 16 observing area for 3 separate piers. And then attached to the observing area was what we called the warm room, which was kind of a misnomer. It really wasn't a warm room, but in traditional observatory lingo, that's where the controller would sit while the telescope was exposed to the night sky. Our warm room was rather a place where the controls for the roof and a storage area for all of the stuff that we needed in order to operate this building remotely. So it was a roll-off roof observatory, and when the roof rolled off, it rolled off to the right of the diagram. And so the warm room was always covered while the area where the piers were was left open to the night sky. And my pier, since I was the third guy to join, was number 3. To give you an idea of what that looks like, here's a screen grab from the interior of the observatory, and you can see my scope is in the foreground there, and the other scopes on our piers in the background. You can see that the walls are about 7 feet tall, and the roof is high enough so that the roof can be opened and closed even when the telescopes are not in the closed position. And we thought that was an important thing to do in order to close the roof in an emergency situation when we might not be able to park the telescopes. But normally the telescopes are parked in the positions as you see them there. You'll notice in the middle there, there's a bright thing in the background. That's the infrared light on one of the closed circuit TV cameras, which are located around the building, so that we could view the scopes from various different angles. And this was very helpful if you were trying to decide whether or not your scope was pointing in the right direction. Well, it quickly became apparent that you needed more equipment than I already had in my backyard observatory in order to do remote imaging. And this is a laundry list of the stuff that we had to invest in order to make that happen. So it was important to have a separate PC at each pier to control the scope, and then another PC or 2 in the warm room to operate the other functions, such as the roof control. And so I think you saw in the previous slide, there was a small cart next to my pier, and on that cart was a desktop computer that was responsible for operating my particular scope. We also had to have a way to access the building, and again, that was done through a typical router that was accessible with port forwarding, so that each of us could control our individual scopes as well as have control over the roof. And I'll explain a little bit more of that as we go along. Another important item was a digital switch, and that was to allow you to activate various different components of your equipment remotely over the internet. Of course, for the safety, we needed to have uninterruptible power supplies for each of the imaging PCs, as well as for the computer that controlled the roof and for the roof motors themselves. As you saw in the image, we had some CCTV cameras located around the perimeter of the building so that we could view the interior as needed. And those cameras came with infrared lights that turned on in complete darkness. I also found out that I needed to somehow be able to monitor my mount so that if something happened, the mount could be counted on to do the right thing. And I'll explain that in some more detail here in just a moment. We also needed a mechanism for taking sky flats, and I'll show you an example of that. And of course, it was very useful to have some way of looking at the sky from the remote site. So that meant an all-sky camera. And then we later added a sky monitoring device to give us a bit more information about what was going on in that local environment. So the digital switch is kind of the typical one that you'd find. This is one that we decided to use, and I think all 3 of us went with the same device. This is from Digital Loggers. And basically, this is a device which hooks up to the internet and has its own static IP address and allows you to activate 8 of the outlets that are located there. The thing comes with 8 programmable outlets and 2 always-on outlets, so that you could have some equipment that was always operational and others that you could turn on and off as needed. And so you see on the menu below there what was set up, how I have mine set up. The digital switch was important because, again, you could turn on various different components of the imaging system as needed, or with some batch file, you could turn on everything all at once, kind of like you do in Nina. You turn on individual devices or just say connect everything. So you see there the things that I had connected. My STL 11,000 was on outlet 3. My AP 900 and the focuser was on outlet 7. And you see a couple there that say do not use. And I'll explain what that means in a few minutes. And number 8 was a water pump. It turns out that the STL 11,000 back in the day supported water cooling, so that in warm weather you could pump water through it with a submersible pump in order to get the cooling down 5 to 10 degrees cooler than would have been possible with just air cooling. Unfortunately, I didn't drain the water from it frequently enough, and that got occluded and became useless after a couple of years. So that was a mistake that I made. You'll notice at the bottom too there, you can turn all outlets on, or cycle the outlets. And the digital switch also had a setting to tell you what to do with each one of those outlets in the event of a power outage. That was very important for remote imaging, because if you were in the middle of an imaging run and your scope was dutifully tracking across the sky and the power went out, of course, the scope would stop tracking. But what would happen when power came back up? Might be an hour later, might be a day later. You would want to be sure to know that the scope did the right thing. And so it was important to have a digital switch so that you could say, well, if the power goes out and the power comes back on later, I don't want you to activate outlet number 7. I want you to just leave outlet number 7 off so that the scope remains where it was when the power failed, and then I can go figure out how to get it back to its home position. So the digital switch was a very important device. You can see that the Dell computer and the monitor are in the on position. They weren't in the always on outlets, because every so often you would need to perhaps cycle the computer to get it to reboot. And again, it was important to have a computer that would reboot and boot up remotely so that you could power it on and off and have it do that when needed. The roof control, there were commercially available roof controls when we put together our observatory, but we had the benefit of Andy, the software engineer, who decided that he would make our own roof control. And so we were lucky to have this. And basically, this is an Arduino-based device that he wrote the software for. And as you can see there, we could connect it. It connected by a USB cable to the roof controller. And there was a small cartoon there, so that we punched one of those icons, close, stop, or open. We could remotely open or close the roof through an Arduino that had relays that would activate the roof motor. And you can see right below that, he very wisely wrote in some software so that the roof would automatically close either before or after a particular event. In this case, we usually have it set to automatically close 45 minutes before dawn. And of course, the software kept a calendar so that it knew when dawn occurred at this particular location every day. And so we could image all night and then go to bed and not worry about the roof closing 45 minutes before dawn. Over on the right side, you see there's a little box that says safety and another box below it that says watchdog enabled. The watchdog was basically a dead man switch. And its whole purpose was it kept getting input from the roof controller software. And if for some reason the roof controller software went away, in other words, if the laptop that was running it died, or the USB cable fell out or became disconnected for whatever reason, the watchdog would activate the uninterruptible power supply to close the roof. And so that was a very useful feature. It only maybe happened a couple of times in the 10 years we've had it. But we did have also a weather monitor that monitored the wind. And you see that there's some settings down there below. And basically, when you click on that, it allows you to determine how much wind you think your roll-off roof can handle. So we typically had it set to send us a warning if the wind got above 15 miles an hour, or if the gusts were exceeding 20 miles an hour. And typically the roof controller would send a text message to our phones saying that if you don't do something, I'm going to close the roof in 3 minutes. So we could go in and override it if we thought it was a false alarm. But in general, if you're doing something else while this operation is going on, it's very useful to have the safety monitor available to close the roof if you're sleeping. You also see in the bottom left-hand corner there, Andy programmed in to turn the video cameras off 5 minutes after the roof opened. And that was kind of important because those infrared lights on the video camera were designed to protect against burglars, and they stay on as long as it's dark. So you have to manually turn them off. And he programmed that into our roof controller so that when you open the roof, they stay on for 5 minutes and then they go off. But you can come back and click them on if you need to make sure your scope is not doing something unusual. So that's our roof controller. Andy also designed for me and for himself, because he had an astrophysics mount, a device to keep track of where the mount was. Some modern mounts do this automatically. For example, the astrophysics mounts now have APCC, which is a software package that you can buy along with the mount that does most of what I'm going to describe here. But basically, the mount watcher that was designed for my particular application was, again, an Arduino-based device that hooked up to the imaging computer with a USB cable. And it basically had power relays that controlled the voltage coming from the 12-volt power supply to the mount. And the mount watcher device sat between the power supply and the mount itself. So when the mount watcher is connected, and as it is in this case, it directs power from the 12-volt power supply, which has been switched on by the digital switch, but the power actually gets to the mount when you connect the mount watcher and tell it to connect to the mount. And it connects to the mount. And again, you can select the type of mount you have. And then it displays the information that you see there below. And it does all this by looking at the ASCOM driver that's controlling the mount. And so this allows us to keep track of where the mount is and to make sure that if something happens, that the mount doesn't run away. So there's really two functions going on here. Up in the top right-hand corner, you can see the word watchdog again. And we had a very similar device here. The software feeds information to the Arduino device, and if for some reason that information stops because the imaging computer goes offline or there's a power failure, the watchdog causes the mount to park. If the other function is the software looks at the ASCOM driver and reads the information from the driver, and that's what you see displayed in the box there. And you can see that I have stopped tracking at 5 degrees past the meridian or 2 degrees past the counterweight up. So if for some reason the mount doesn't do a meridian flip, and it goes through the meridian. Shortly thereafter, the mount watcher is going to tell it to stop tracking. It doesn't park the scope, it simply cuts off tracking via the ASCOM driver, and it sits there and waits for the user to come along and decide what to do next. And this has saved my ass on several occasions. You can imagine what happens if you lose internet connection either at the remote site end or at your home site or wherever you happen to be. You're basically then flying blind, and any imaging run that you've started is going to continue on until something tells it to stop. Either it concludes successfully or the mount runs into something that causes it to stop. So this type of device is extremely important for making sure you know what's going on with the mount. I think a few years ago we talked about calibration, and I think I showed some slides of the flat frame device. The one that we decided to use, myself and a couple of the others in the observatory, was the Spike-A-Flat adjustable flat panel. Unfortunately, the Spike-A-Flat folks went out of business and it's no longer available, but other devices similar are. And it's basically mounted on the wall. You see my scope there in the park position. It always points at the flat panel when it's in the park position. So to take flats, I can simply turn the camera on. I don't have to activate the mount. And the flat panel is adjustable. It hooks up to the imaging computer with the USB cable. You turn the lights on, and then you can adjust the brightness up or down so that you can take flats that last 1 or 2 seconds because you've adjusted the brightness for whatever filter you're using. And so there are other devices like this that are available, but obviously you do need to take flats at times when you get dust on some of the optics, and the flats tend to change on you. And if you're using a rotator, you may want to take flats that match the rotation of the device. So a device like this that can be operated remotely through the imaging computer is essential. Any questions so far?
Yes.
Go ahead.
This is all new to me, this whole remote observing. How remote are you? How far how remote is remote?
As remote as you want to be. When I was in St. Louis, I was 1,800 miles away.
Wow. Okay.
Now I'm only about 2.5 hours away, but it's still remote.
Yeah, sure. Okay.
Okay.
Yeah, I'm strictly a backyard guy.
Anywhere you have internet access, basically.
Okay.
Okay. Good question. Okay, we also had an all-sky camera that we put together, one of those home-built ones with a little dome, and I think it's an ASI 120 mm. Basically points up and shows us what's in the sky above the remote site. There's also a sky monitor that gives us a kind of a reading of the what the night sky looks like in terms of the full width half max. And on this particular site, there's also some other folks that have Boltwood monitors, so we can get things like wind speed and wind direction and those types of things to help us decide when it's appropriate to open the roof or to close the roof. It's weird, no matter how careful we are when we visit to clean the dome, almost the next day, immediately some bird decides to poop on the dome. We actually have pictures of birds sitting on the all-sky camera. So this is kind of my basic imaging workflow. It's pretty simple and straightforward and not much different than you do in your backyard. First of all, when the conditions are appropriate, it's clear and it's not windy, we open the roof. And any one of the three of us can open the roof because we all have access to the roof controller. We have a digital log on the roof control laptop, so we kind of sign in and say, I opened the the roof at X amount at a certain hour. I'm going to close it at midnight because there's clouds coming in, or if we do close it before the sun comes up, we usually put a note in as to why we closed. Next, very straightforward, power up the mount, camera, and software. And then I usually slew to a target somewhere in the vicinity of a star, somewhere in the vicinity of the target, and do a plate solve and a sync, similar to what you do in most other control software. Once that's accomplished and I'm satisfied that the scope is pointing where I think it's pointing, then I slew to the target and image using a scripting program. The scripting program, sometimes if it runs all night on a single target, it does the meridian flip. And then when the script is complete, it parks the scope and sends me a text message that the script has been complete. We were using regular text messages, but AT&T and some other providers stopped allowing you to send text messages to phone numbers. And so I've adopted what a lot of folks are using in NINA, and that is pushover, which does basically the same thing. You do a one-time subscription, and then you use pushover to send messages from your remote device to your phone or to your tablet, telling you what the status is. So if there's you can have a script set up for errors that occur, like clouds roll in and you can't find a guide star, or when the imaging script completes and the scope has been parked. So in terms of workflow, I store all of the images that are collected in a work folder. It's a common folder, so every image that I get goes into that folder, and that's because the scripting program that I use has a rolling index, and it'll never overwrite a file, even if the file has the same name. And MaximDL, which I use to control the data acquisition, does the same thing. It looks at that work folder, and if it sees NGC 1333 red number 13, it knows that the next red image is going to have to be number 14. And the scripting file does pretty much the same thing. So this allows me to set up an imaging script and let that imaging script run night after night with the images going into the folder, never worrying about them being overwritten. And then when I've completed the data collection on that target, I move that raw data to a separate folder with the date and name of the target, and that's what gets downloaded to my home desktop for image processing. And again, as I pointed out before, the roof closes if there's a weather alert or before sunrise. So in terms of connectivity, when I first started, I was using Real VNC. They had a free version that worked great, had a lot of features, and it had viewers for both Windows and iOS. And that was really a good idea. So you load the server on the remote PC, you load the viewer on your device, and then you can log in wherever you have internet connection and see what's going on. Unfortunately, Real VNC got popular, and so they went to a paid version. So the free version was there, but if you wanted to transfer data, you had to pay. And then they went to a cloud version, which cost even more. And then they upgraded their software last year, which was not backward compatible to Windows 7, which is what we're still using for those computers running at the side of the imaging device. So I had to abandon Real VNC, and it was about $120 some a year at the end there. Type VNC has been around for a long time. It's free for home use, and it also runs on Windows, Linux boxes, Mac OS as well, and iOS. And it is capable of file transfer. And of course, as I showed you in my workflow, I download the files after the fact, and so that's an important feature. It turns out that the real VNC viewer is also compatible with Type VNC, and it allows me to look at my remote device, whether I'm on my desktop running Windows, my iPad running iOS, my iPhone running iOS, or wherever I happen to be. So a couple of nights ago, I was at a University of Arizona basketball game, checking in on my remote imaging while it was going on while I was watching basketball. The download speeds are not what you'd think about. The remote site that we're at has fiber optic cable, and we have high-speed cable at my home, but the typical download speeds are not instantaneous. And you see they're typical greater than 2 megabytes. Typically, what we've experienced is anywhere from 2 up to 10 megabytes. And it really kind of depends on how many people are accessing the routers at the same time. So you might be surprised when you see some of the advertisements about how fast the download speeds are from remote sites. In general, they tend to be a little bit slower than you might anticipate. So just to give you an idea of the productivity, this is a graph of how many targets I imaged over the past 10 years. That's the orange bars. You can see the first few years it was around 100. In 2019, I had to take the camera down for servicing, and so I lost a month and a half, and so I didn't get quite as much data that year. But in the years since then, it's gone up, and the blue bars are the amount of data that I've actually stored based on what's come from the remote observatory. I don't save any raw data. I don't save the uncalibrated or calibrated raw data, but I do save the calibrated master stacks and any intermediate images that are made in post-processing. And so you can see that in the last year there, I accumulated about 80 gigabytes of data that I store permanently. But the number of targets that I've been able to acquire over the 10 years, you can see, is sizable. And in 2024 there, I got on a binge of trying to complete some of the Astronomical League's challenges where you have to image 100 open clusters and things like that. So there's a lot of data that was collected there in pursuit of those challenges. So what are some of the problems that we've run into? Well, of course, there's computer malfunctions, and some of those were as simple as having someone who's on site go over there and press the F1 key to hit the reset, so the thing would boot up. But many times it wasn't. So I had an instance where the power supply died. I hauled the PC home. I installed a new power supply, took it back. Everything was fine. I had a really unusual keyboard instance. There's a keyboard on the cart next to the imaging device. And for some reason, even though the keyboard's covered with a towel to keep the dust out of it, it decided to have a key go bad. And the key that went bad was the delete key. So when this happened, every time I clicked on something on the remote desktop, it said, do you want to delete this? That's all it would do. Fortunately, my observatory mate, Dan, the telecommunications IT guy, installed a keyboard monitor remotely that blocked the delete key from being active. And that worked really good until I decided that it interfered with meridian flips, which I won't go into, but basically it took me about a month to figure out that it was the keyboard that was the problem. So I bought a new $15 keyboard and had the remote folks just plug it in, and everything's been good since then. Most of the roof malfunctions that we ran into have to do with that little switch that you see in the corner down there. That's the sensor that determines when the roof is open or closed. The ones in the closed position are inside, and they do just fine, but the ones out in the weather don't last very long. So I've personally replaced these a couple of times, as well as having the folks on site replace them, and we keep a supply of them handy. They're only about $7, but they don't last more than a couple of years out in the hot desert sun. And when they go out, you lose the ability to know whether the roof's open or closed. We have duplicates on both sides, but when one of them goes out, it usually starts throwing errors. The biggest problem, as I've already alluded to, is when the remote or the local internet service goes down, and that's when you have to have some way of making sure that the mount doesn't just keep going forever until you reconnect with your remote computer. We have had remote power failures like everybody else here in the desert Southwest. When the storms come through during the summer, the power does go down. That happens just about everywhere, and that's where having the ability to determine what happens when the power comes back up is very important. And as I already told you, the digital switch is one of the ways of managing that. Camera issues, I really didn't have a lot of camera issues. I did send the camera back just to be retrofitted with a few different features. I did have a filter come loose, which caused me all kind of problems because sometimes the camera would work, then every once in a while it would stick. The STL 11000 has an internal filter wheel, and the filters are held in place with little screws, and after about 7 or 8 years, one of those little screws came loose, and then the second little screw came loose, and eventually the filter fell out. And so eventually that kept the filter wheel from turning completely, and I had to make a maintenance visit. The digital switch, as you saw when I showed you the picture, had 2 of the outlets blocked or said do not use. That's because they went bad on me. I'm not sure why they did it, but the longest downtime that I experienced was 3 months. When I would power up, everything would look good, and then a few minutes later, the mount would disconnect. So I replaced everything, all the cables, the controller, everything, and nothing seemed to solve the problem until one of my compatriots was on site, and he said, well, let's plug it into a different outlet. And he plugged it into a different outlet, and everything was fine. So the digital switch has a couple of outlets that have failed. We did have a lightning strike back in 2024, and the lightning strike fried the roof controller, fried the Arduino. And unfortunately, in the process of frying the Arduino, it caused the Arduino to open the roof. So not only did we lose the roof controller, but all the equipment got rained on. Fortunately, it didn't cause a lot of damage, but I think the rain did have something to do with one of the outlets on the digital switch going from good to bad. So those are some of the things that we've encountered that caused some consternation. So what do I regret? Well, I didn't anticipate or plan to be there for 10 years. I didn't really think about that when I plucked up my pier and my imaging equipment and moved it across country. And so I think if I had to do this over again, I would try to think about what's the best way to get this going, and then also be able to improve on it or make it better. Along those same lines, I've been relatively complacent because what was working 10 years ago is basically still working now. The camera is basically on its last leg, although it still operates. It's not very efficient compared to the CMOS cameras that most of you use now. And the state-of-the-art gear that I bought back in 2007, 2008, and moved in 2016 isn't state-of-the-art any longer. It probably wasn't state-of-the-art for very long after I moved it. So those are the things that I would have to seriously consider doing differently. So I just like to share with you at the end here, by the numbers, here's some of the good and bad stuff that I think is kind of interesting. Lightning strikes, we had one, and it really caused a big problem. Polar alignments, I did it once in February of 2016, and it's been pretty much the same ever since then. I did get one APOD out of the images I took over the 10 years. As I said, we had to replace the roof controller once. I've had to replace PCs 3 times for various different reasons. The longest downtime, again, as I talked to about just previously, was 3 months. I've had to make 6 maintenance visits. One was from St. Louis, but the other ones have been from here in Tucson. It's a much shorter drive to southwest New Mexico from Tucson. In terms of imaging, as you saw from the productivity slide, I've achieved 9 Astronomical League awards. I've had 33 images published in print. The longest exposure from the remote observatory was 53 hours. And I can't read the bottom there, but I think it's 89 or 79 comets imaged, 79 different comets. So I'll show you just a few pictures just to give you a feel for what I feel has been a good investment in time and effort. This is from 2016. This is the Snake Nebula B72. And this is one of the full frame images from the STL 11,000. This is from 2017, NGC 1333. Dust that a lot of you can now capture with your more sensitive CMOS cameras, but this wasn't visible from my backyard in the suburbs of St. Louis, but it certainly was from the dark skies of New Mexico. Of course, my camera only has 5 places in the internal filter wheel. One of those was taken up by an HA filter, so I have imaged a lot of the sharpless objects since they shine in HA for the most part. And this was one of AISIG Sharpless 2311 from 2018. Again, M33 using only a portion of the full frame with some added hydrogen alpha to show up the appropriate nebula in this particular galaxy. In 2020, I was fortunate to capture Comet M3 Atlas as it graced its way past NGC 1893, the Tadpoles Nebula, if you remember that one. So this was an instance where I had a picture of the Tadpole Nebula, and my planetarium program told me that the comet was going to be in a neighborhood. So all I had to do was wait for the comet to get there, appropriately image the comet, and then combine those 2 images to come up with the image that you see here. Along the same lines, I did pretty much the same thing with Comet Leonard in 2021 when it passed directly between NGC 4631 and 4656, the whale and the hockey stick. And again, I imaged those galaxies in anticipation of the comet arriving, and then just had to wait for a clear night for the comet to get there. And fortunately, everything went along with that. In 2022, I began imaging a lot of ARPs because once you've imaged a lot of targets, all the big bright stuff has been imaged several times. So I got interested in looking at some of the peculiar smaller galaxies in the ARP catalog. And again, used a lot of those images to earn the Astronomical League Challenge for imaging 105 different ARPs. In 2023, I did the same thing for open clusters, and I thought this was an interesting one because there's 2 NGC clusters and a King open cluster in the same field of view. And so that was something that I did a lot of during times when the moon was either full or partially full, when imaging other deep sky objects wasn't on the menu. In 2024, this is a wide field image of the small Sagittarius cloud. And again, this was using the full frame of the STL 11,000. This was just a 55-minute exposure in RGB. Last but not least is the comet, which was most recently in our sky comet A6 Lemon, which I imaged last fall. So I'm going to stop there. I went way longer than I had intended to. This is my website where you can find the images that I've been talking about if you're so inclined. And I'll be happy to field any questions.
Greg, without your two partners who seem to really know a lot, would you have done this?
Yeah, probably no and no. Probably if I wouldn't have gone by myself, I don't think. And what got me into it was the fact that I had two people who knew a lot about the nuts and bolts of what was required to actually make this happen. Along the way, those two guys have helped me on innumerable occasions. So, for example, when the lightning fried our Arduino roof controller, we were kind of out of business until we could get a new roof controller. So Dan got an Arduino. Andy programmed it remotely. Dan shipped it to the observatory, and I drove up there and installed it. And we got it going within a few weeks. So those are the kind of things that makes it worthwhile to have either on-site assistance where they really know what they're doing, or to have good help that you can rely on that can solve a lot of problems remotely.
What kind of services are available locally there? And
There's
New
on-site
Mexico.
personnel there. If you look at, remote imaging has become somewhat popular. And so there are a lot of different places now getting into the business of, bring your equipment down here. We have these pristine skies, clear nights, 200 nights, 250 nights a year, whatever they claim. And there's a lot of places that do that. And the prices range kind of all over. So it really, you kind of have to pay close attention. And hopefully, some of the stuff that I've shared with you tonight give you some food for thought if you're thinking of taking your equipment to a remote location, or sending your equipment to a remote location where they say, send your equipment down, we'll set it up and take care of it for you. Other questions or comments?
it's way more technical than I even thought it might be.
It is and it isn't. The benefit, I think, outweighs the risks. And that's why I haven't removed my gear yet. So those of you who have backyard setups or backyard observatories know it's nice to have the scope already at ambient temperature and ready to go as soon as you power up and let it cool down and you're ready to go. And that's kind of done on steroids if you have a remote observatory where it's clear many nights more than it might be in your home location. We're kind of fortunate here in the desert Southwest because we have a lot of clear nights, whether you're in your backyard or in a remote location.
Well, I found it fascinating. I don't think I'll ever plan to do it. Probably a strictly backyard guy, but very interesting.
Never say never.
Okay.
I noticed, Greg, that do you never have a lens cap on your telescope?
No.
Does it get dirty faster?
Well, as you saw the telescope parked, it's in a horizontal position. And there is a lot of dust blowing around, and our observatory is not airtight because of the roll-off roof. And obviously, if you're imaging 200 nights a year, the thing's sitting outside a lot. But in terms of dust, we were pleasantly surprised, both Dan and I, who park our scopes in a horizontal position pointing at the flat panel. When we go up there and look at the optics, they're relatively clean. Now, the other optics that are in the imaging train, sometimes those become more dust coated than the primary. But in general, parking the scope in a horizontal position has been relatively good at keeping dust off the primary objective, at least for the Newtonian scopes. I did haul the scope home back there in 2019 and, take the mirror out and hose it off. But that's the only cleaning that it's gotten. But there are devices, flat frame devices that hook onto the front aperture so that the flat device is also a scope cover. And I can see where those would be useful in a lot of instances, particularly if you want to take easy flats. Any other questions?
That
Other
was a great
comments?
presentation.
Okay, thank you. Well, if there are no other questions, I'm going to again remind you our next meeting will be on March 16th. And we'll publicize the topics for that meeting sometime in the near future. I don't know if Jeff made it in time for this meeting, but I'm sure he wants to remind the folks who signed up for the get-together at CAT that the dates for that, weather pending, are April 12th and 13th. That's a Sunday and a Monday. So you should have received email from Jeff if you signed up for that. Again, if you would like to submit images for the Desert Sky Bulletin, you can send those to me. Please try to make them less than 10 megabytes so that we don't have trouble getting them into the bulletin. If you have suggestions for topics, please feel free to contact me or Jeff Rothstein. All right, I'm going to stop sharing my screen, and if there are no other questions, we'll call that all for this month. Thanks, everybody.
Thank you, Greg. It was
Thanks,
great.
Greg.
Great.